In the hazy borderlands between consciousness and oblivion, something remarkable happens every night. Your brain constructs elaborate worlds, populates them with characters drawn from memory and imagination, and weaves narratives that can range from the mundane to the impossible. Yet by morning, these vivid experiences, dreams that may have seemed profound, terrifying, or revelatory just hours before, often vanish like morning mist, leaving behind only fragments or nothing at all. The phenomenon is so common that most people take it for granted. You close your eyes, enter a state where your consciousness transforms in fundamental ways, experience adventures that can feel as real as waking life, and then wake with barely a trace of these nighttime journeys. What causes this peculiar amnesia? Why do dreams, which can feel so significant while we experience them, slip through our mental fingers so easily? This question has fascinated humans throughout history, from ancient civilizations who saw dreams as divine messages to modern neuroscientists mapping the electrical activity of the sleeping brain. The answer lies at the intersection of neurology, evolutionary biology, psychology, and biochemistry, a testament to the astonishing complexity of the human mind. To understand why dreams fade, we must first understand what they are and how they form in the biological theater of our brains. Every night, as you drift into sleep, your brain passes through distinct stages, each with its own neurological signature. Dreams occur primarily, though not exclusively, during rapid eye movement REM sleep, discovered in 1953 by Eugene Aserinsky and Nathaniel Kleitman at the University of Chicago. Their groundbreaking research revealed that during REM sleep, brain activity resembles the waking state in many ways, despite the body being effectively paralyzed, a condition called REM atonia. During REM sleep, your brain exhibits a fascinating electrical pattern. While most of your body rests, your brain bustles with activity. Neurons fire in patterns similar to when you are awake, but with a crucial difference. The neurotransmitter cocktail is altered significantly. In particular, levels of norepinephrine and serotonin, chemicals crucial for attention, memory formation, and emotional regulation, drop dramatically. Dr. Nadine Foster, a neurobiologist at the University of California, explains this chemical shift. The brain during REM sleep operates under a fundamentally different neurochemical environment than the waking brain. It is as if the brain is running on an alternative fuel mixture, one that promotes certain types of cognitive activity while suppressing others. This altered chemical state proves critical to understanding dream amnesia. Memory formation is not a single, simple process, but rather a complex, multi-stage phenomenon requiring specific brain chemicals and activities. When we form memories while awake, information passes through several stages. Encoding, where experiences are translated into neural patterns. Consolidation, where these patterns are strengthened and integrated with existing memories. And retrieval, where these patterns can later be accessed consciously. The brain's memory systems evolved primarily to remember experiences from waking life, threats, resources, social interactions, and other information relevant to survival and reproduction. Dreams, by contrast, are internally generated experiences occurring during a state where memory systems operate differently. The brain's memory-forming mechanisms are simply not optimized for capturing experiences that occur during sleep. Zachary Wilson, a cognitive neuroscientist at MIT, has spent decades studying memory formation during different states of consciousness. The hippocampus, a brain structure critical for transforming short-term memories into long-term ones, operates differently during REM sleep than during wakefulness. Wilson notes, during REM sleep, the hippocampus shifts from its typical role in memory, encoding to one focused on memory consolidation of the previous day's experiences. This shift in hippocampal function represents one of the first major obstacles to remembering dreams. While you dream, your brain is not prioritizing the formation of new memories about the dream itself. Instead, it is working to strengthen and organize memories from your waking hours. Your brain, in essence, is too busy filing yesterday's memories to properly record the dream you are currently experiencing. But the story does not end with the hippocampus. Another crucial factor involves the prefrontal cortex, an area associated with executive functions, attention, and working memory. During REM sleep, activity in the prefrontal cortex decreases significantly. This reduction means that while dreaming, you lack the attentional focus and executive control necessary to deliberately commit experiences to memory. Think of it this way. When you are awake and wish to remember something important, a new acquaintance's name, for instance, you consciously direct attention to that information. This deliberate focus helps encode the memory more strongly. During dreams, however, your prefrontal cortex is not fully engaged, making this kind of intentional memory formation nearly impossible. The role of attention in memory formation cannot be overstated. Studies conducted by Dr. Elizabeth Loftus, a pioneering researcher in memory formation, have repeatedly shown that memories formed without attention are fragile and easily lost. Without the prefrontal cortex's full participation during dreams, experiences that would be memorable while awake become ephemeral when sleeping. Dreams also suffer from what scientists call state-dependent memory, the phenomenon where information is better recalled when you are in the same physical and mental state as when the memory formed. Since dreams occur during a unique brain state quite different from wakefulness, waking up creates an immediate barrier to recall. The sleep state in which the dream occurred and the waking state in which you try to remember it are simply too different. This state-dependent effect explains why dream recall often improves when you wake directly from REM sleep. If you wake while still in or close to the REM state, the transition between dreaming and waking consciousness is less abrupt, giving you a brief window where recall is enhanced. This explains why dreams remembered in the middle of the night often feel vivid but may be completely forgotten by morning. The biological basis for state-dependent memory involves specific patterns of brain activity and neurochemical environments. When you learn something in a particular brain state, the neural patterns encoding that information become associated with the broader context of brain activity present during encoding. When you later attempt to retrieve this information, similarity between the current and original brain states facilitates recall. Dr. Foster elaborates, if you learn to play piano while intoxicated, you might perform better while intoxicated than while sober. The same principle applies to dreams. The dramatic shift in brain chemistry between sleeping and waking creates a retrieval barrier. Another factor in dream forgetting involves a neurotransmitter called acetylcholine. During REM sleep, acetylcholine levels remain high, similar to waking levels, while other neurotransmitters drop. This chemical imbalance promotes the internal generation of experiences, dreams, while simultaneously interfering with the brain's ability to form episodic memories of those experiences. Research conducted in 2004 by Matthew Wilson and Daoyun Ji at MIT revealed another fascinating aspect of dream amnesia. By recording the activity of rats' hippocampal neurons during both wakefulness and REM sleep, they discovered that similar neural patterns activated in both states. The sleeping rats appeared to replay patterns of neural activity from when they navigated mazes while awake. However, these patterns during sleep occurred at a compressed timescale and lacked certain neural signatures associated with successful memory formation. This study suggests that dreams may partially represent the brain processing and consolidating memories from waking experiences, but in a form not optimized for later conscious recall. Dreams, in this view, are not meant to be remembered themselves. They are the brain's work of processing other memories, not experiences to be encoded as new memories. The evolutionary perspective offers additional insight into why dreams might be designed to fade. From a survival standpoint, clearly distinguishing between memories of real events and memories of dreams would be advantageous. Imagine early humans confusing a dreamed encounter with a predator for a real memory. Such confusion could lead to maladaptive behaviors based on false information. There would be significant adaptive disadvantage to treating dream content as equivalent to waking memories, explains Dr. Malcolm Roberts, an evolutionary psychologist at Cambridge University. The forgetting of dreams may represent an evolved feature rather than a bug. a way for the brain to separate imagined scenarios from actual experiences. This evolutionary hypothesis gains support from studies of individuals with certain neurological conditions who have difficulty distinguishing memories of imagined events from memories of real experiences. Such confusion can lead to significant functional impairment, suggesting that clear boundaries between remembered reality and remembered dreams serve an important purpose. The relationship between dream content and forgetting adds another layer of complexity. Studies conducted at sleep laboratories have consistently found that emotionally neutral dreams are forgotten more quickly than emotionally charged ones. Dreams eliciting strong emotions, fear, joy, anger, tend to be remembered more readily than mundane scenarios. This pattern aligns with general principles of memory formation in waking life as well. Emotionally salient experiences receive preferential treatment in memory systems, likely because emotional events often carry survival-relevant information. The amygdala, a brain region critical for emotional processing, becomes active during emotionally charged dreams and helps strengthen memory formation despite the chemical environment that generally inhibits it. Dr. Robert Stickgold of Harvard Medical School has conducted extensive research on sleep, dreams, and memory consolidation. His work suggests that dreams represent the brain's attempt to integrate new experiences with established memory networks, a process that may not require conscious recall of the dreams themselves. The dream is not the end product, Stickgold explains. It's the integration process itself that matters. The content of dreams, which we rarely remember, reflects the brain making connections between recent experiences and older memories, identifying patterns, and strengthening useful associations while weakening irrelevant ones. This perspective positions dream amnesia not as a failure of memory but as a feature of a system working as designed. Dreams serve their purpose whether remembered or not, perhaps even better when they fade, having accomplished their integrative function without cluttering conscious memory with their surreal narratives. The transition from sleep to wakefulness presents another significant barrier to dream recall. Upon waking, the brain undergoes a rapid state change, with neurochemistry shifting dramatically in seconds. This abrupt transition creates what memory researchers call interference, new sensory input and cognitive activity that disrupts the fragile traces of dream memories before they can be properly consolidated. Dr. Zachary Wilson likens this to trying to photograph a sunset while simultaneously driving a car. Upon waking, your brain immediately begins processing sensory information, thinking about the day ahead, and reorienting to your physical environment. These activities compete for the same cognitive resources needed to consolidate dream memories, often resulting in those dreams being overwritten before they can be stored. This interference effect explains why dream recall improves when you remain still upon waking, keeping your eyes closed and focusing attention on any dream fragments you can remember. By minimizing new sensory input and cognitive demands, you reduce interference and give dream memories a better chance of consolidation. Some individuals report significantly better dream recall than others. These differences appear to result from a combination of factors including genetics, personality traits, interest in dreams, and practices that enhance recall. Studies have shown that simply keeping a dream journal and developing the intention to remember dreams can dramatically improve recall over time. The phenomenon known as lucid dreaming, becoming aware that you are dreaming while still in the dream state, offers intriguing insights into dream amnesia. Lucid dreamers often report much better recall of their lucid dreams compared to ordinary dreams. This enhanced recall likely stems from greater activity in the prefrontal cortex during lucid dreaming, allowing for the conscious direction of attention that facilitates memory formation. Research conducted by Dr. Ursula Voss at Goethe University in Frankfurt has demonstrated that lucid dreaming correlates with increased gamma-wave activity in the brain, a type of neural oscillation associated with conscious awareness and attention. This finding suggests that increasing certain types of brain activity during dreams might bridge the gap between sleeping and waking cognition, potentially enhancing memory for dream experiences. Technological innovations are beginning to offer new windows into dream content and potentially dream recall. In 2021, researchers at MIT developed a system called Dormio that detects when users enter the hypnagogic state, the transitional period between wakefulness and sleep, and delivers audio cues to influence dream content. This research suggests that external intervention during specific sleep phases might eventually help improve dream recall, or even allow recording of dream content. While such technologies remain in their infancy, they point toward future possibilities for better understanding the relationship between dreaming and memory. As Dr. Natalia Fuller, a sleep technology researcher, notes, "We are just beginning to develop tools that might eventually allow us to bridge the gap between dream experiences and waking recall. The implications for understanding consciousness itself are profound. Beyond the neurobiological factors, psychological and cultural influences also shape dream recall. Societies that place high value on dreams tend to produce individuals with better dream recall. For example, certain indigenous cultures that consider dreams important sources of wisdom or prophecy typically report more extensive and detailed dream memories than individuals from cultures that minimize the significance of dreams. This cultural effect likely operates through several mechanisms. First, cultures that value dreams often have practices that enhance recall, such as morning dream-sharing rituals or dedicated dream journals. Second, the expectation that dreams should be remembered creates a psychological priming effect that improves actual recall. Finally, regular discussion of dreams strengthens neural pathways associated with dream retrieval, making the process more efficient over time. Individual psychological differences also influence dream recall. People with certain personality traits, particularly openness to experience and thin psychological boundaries, typically remember more dreams. These traits correlate with heightened sensitivity to internal psychological states and greater attention to subjective experiences, both factors that would enhance dream recall. Mental health conditions can dramatically affect dream experiences and recall. People with post-traumatic stress disorder often experience recurring nightmares that may be remembered with disturbing clarity. Certain types of depression can increase dream recall, while others suppress it. Anxiety disorders frequently correlate with more negative dream content and sometimes enhanced recall of those negative dreams. Dr. Natalia Fuller explains, "The relationship between mental health and dream recall highlights the complex interplay between emotion, attention, and memory systems. Strong negative emotions can sometimes pierce through the usual forgetting mechanisms, leading to persistent recall of disturbing dream content. Sleep disorders provide another window into dream amnesia. People with narcolepsy, a condition characterized by excessive daytime sleepiness and sudden sleep attacks, often report unusually vivid dreams and enhanced dream recall. This phenomenon may result from narcolepsy's disruption of normal sleep architecture, causing REM-like states to intrude into wakefulness and creating a blurred boundary between dreaming and waking consciousness. REM sleep behavior disorder, RBD, represents another illuminating condition. In RBD, the typical muscle paralysis that accompanies REM sleep fails, allowing patients to physically act out their dreams. These individuals often report excellent dream recall, possibly because their physical enactment of dream content provides additional sensory feedback that strengthens memory encoding. The timing of dreams within the sleep cycle also influences whether they will be remembered. Dreams occurring during the final REM period of the night, typically in the hours just before waking, have a much higher probability of being remembered than dreams from earlier sleep cycles. This recency effect mirrors patterns seen in waking memory, where more recent events are generally recalled more easily than distant ones. Throughout a typical night, REM periods grow progressively longer, from perhaps 10 minutes in early cycles to as much as an hour in the final cycle before waking. This pattern means that late-night dreams have more time to develop complex narratives and emotional resonance, potentially making them more memorable simply by virtue of their elaboration. Pharmaceutical interventions can dramatically affect dream recall. Many common medications, including certain antidepressants, beta blockers, and blood pressure medications, alter sleep architecture and dream experiences. Some drugs suppress REM sleep entirely, while others increase dream intensity or bizarreness. These pharmaceutical effects on dreaming highlight the chemical basis of both dream generation and dream recall. Certain medications specifically affect memory systems without necessarily changing dream content. For example, benzodiazepines and other sleep aids are known to cause anterograde amnesia, difficulty forming new memories, which can further impair already tenuous dream recall. This pharmaceutical evidence reinforces the understanding that dream amnesia stems from specific neurobiological mechanisms rather than something inherent to the dream content itself. The relationship between dreaming and creativity has fascinated scientists and artists alike. Many famous scientific insights and artistic inspirations reportedly came through dreams. From Dmitri Mendeleev's dream of the periodic table to Paul McCartney's dream origin of the melody for Yesterday. These anecdotes raise the question: if dreams typically fade so quickly, how do these creative insights persist? Research suggests that dreams containing potential solutions to problems or novel creative connections may activate reward circuits in the brain, triggering stronger encoding despite the general tendency toward forgetting. Additionally, the emotional impact of a eureka moment might recruit memory-enhancing mechanisms that overcome the usual barriers to dream recall. The content of forgotten dreams does not simply vanish without a trace. Evidence suggests that dream experiences can influence waking behavior and emotions even when not consciously remembered. In one study, researchers woke participants during REM sleep and exposed them to specific scents paired with mild electrical shocks. The next day, even though participants had no conscious memory of these experiences, they showed measurable physiological stress responses when exposed to the same scents again. This finding suggests that dream experiences can form implicit memories that influence behavior without conscious recollection. Such implicit learning during sleep may represent an evolutionary advantage, allowing the brain to prepare for potential threats or opportunities without burdening conscious awareness with the processing behind these preparations. The phenomenon of dream incorporation, where external stimuli become integrated into dream narratives, offers another angle on dream memory. If you have ever had an alarm clock transform into something within your dream, you have experienced this phenomenon. This incorporation happens because the sleeping brain attempts to make sense of sensory information that penetrates sleep, creating dream content that contextualizes these stimuli. Interestingly, dreams that incorporate external stimuli are somewhat more likely to be remembered, possibly because the external stimulus creates a memory bridge between the sleeping and waking states. This connection might facilitate recall by providing a retrieval cue that spans both states of consciousness. Children appear to experience different patterns of dream recall than adults. Young children often report less dream recall despite spending more time in REM sleep, a paradox that has puzzled sleep researchers. This difference may reflect developmental changes in memory systems, differences in sleep architecture, or simply challenges in communicating dream experiences. By adolescence, dream recall typically increases to adult levels, corresponding with the maturation of brain systems involved in metacognition, thinking about one's own thoughts and autobiographical memory. This developmental trajectory suggests that dream recall depends not just on having dreams but on having the cognitive architecture to encode, store, and retrieve them effectively. The relationship between sleep quality and dream recall presents another fascinating dimension. Poor sleep generally correlates with fragmented dreams and reduced recall. However, minor sleep disruptions can sometimes enhance dream recall by causing awakening during or shortly after REM periods, creating opportunities to encode dream memories before they fade. Dr. Zachary Wilson explains this apparent contradiction. The ideal situation for dream recall involves continuous, high-quality sleep with a gentle transition to wakefulness during or shortly after a REM period. Both severe sleep disruption and extremely deep, uninterrupted sleep tend to reduce dream recall, though for different reasons. Circadian factors also influence dream recall. Dreams occurring during morning REM periods typically contain more positive emotional content and more logical narratives than dreams from the middle of the night. These morning dreams are also more likely to be remembered, partly due to their recency but also possibly because their more coherent structure makes them easier to encode into waking memory systems. This circadian effect on dream content and recall highlights the dynamic nature of sleep. Sleep is not a uniform state but rather a constantly changing process influenced by time of day, hormonal fluctuations, and prior sleep debt. These variations create different conditions for both dream generation and dream memory formation throughout the night. Cultural attitudes toward sleep itself may influence dream recall. Modern societies often undervalue sleep, treating it as unproductive time rather than an essential biological process. This devaluation can lead to chronic sleep deprivation, irregular sleep schedules, and increased sleep disruptions, all factors that alter normal sleep architecture and potentially impair dream recall. Dr. Natalia Fuller notes, in cultures where sleep is marginalized and constantly sacrificed for productivity, we see not just health consequences but a kind of collective dream amnesia, a disconnection from this aspect of human experience that has historically been considered valuable across most human societies. Recent research suggests that dream forgetting may serve specific cognitive functions beyond simply distinguishing real from imagined experiences. The process of forgetting both of dreams and waking experiences increasingly appears to be an active, regulated process rather than a passive decay of memory traces. Studies of memory systems indicate that forgetting plays a crucial role in cognitive efficiency, preventing information overload and allowing for appropriate generalization from experiences. Dream amnesia may represent a specialized application of this principle. The brain selectively retains the emotional gist and potentially useful insights from dreams while discarding the specific narratives that delivered them. This perspective aligns with emerging understandings of sleep's role in memory consolidation. During sleep, the brain appears to extract general principles and emotional themes from specific experiences, strengthening these abstract representations at the expense of detailed episodic memories. Dream amnesia may be a byproduct of this prioritization of gist over detail. The significance of dream amnesia extends beyond scientific curiosity. It touches on fundamental questions about the nature of consciousness itself. Dreams represent a form of consciousness dramatically different from waking awareness, raising profound questions about what consciousness is and how it relates to memory. Philosopher and consciousness researcher David Chalmers has suggested that the study of dreams may provide unique insights into the hard problem of consciousness, the question of how and why physical brain processes give rise to subjective experience. The fact that we can experience vivid subjective states during dreams that subsequently vanish from memory highlights the complex relationship between consciousness and recall. Some theories propose that consciousness itself may be broader than what we can later remember. According to this view, dream amnesia represents not a failure of memory but a window into the limitations of memory as a tool for capturing the full range of conscious experience. What we consciously experience may be far richer and more extensive than what our memory systems can preserve. As technology advances, new methods for studying dreams continue to emerge. In 2013, researchers at the ATR Computational Neuroscience Laboratories in Kyoto, Japan, made headlines with a technique for crude visual reconstruction of dream imagery using fMRI data. While still primitive, such technologies hint at future possibilities for objectively recording dream content independently of subjective recall. More recent work using machine learning algorithms to analyze brain activity during sleep has demonstrated increasing accuracy in identifying specific dream themes and emotional tones. These approaches may eventually allow for more reliable access to dream content, potentially circumventing the natural limitations of human dream recall. Beyond technological approaches, certain practices have been shown to significantly improve dream recall. Regular meditation, particularly mindfulness practices that enhance present moment awareness, correlates with improved dream recall. This improvement likely stems from meditation's effects on attention regulation and metacognitive awareness, both factors that support memory formation during transitional states of consciousness. Dream journaling represents another effective method for enhancing recall. The simple act of recording dreams immediately upon waking, even when only fragments can be remembered, gradually strengthens neural pathways associated with dream recall. Over time, many individuals find their dream memories becoming progressively more detailed and complete through this practice. The timing of sleep and waking also influences dream recall. Research has shown that natural awakening without an alarm clock often results in better dream recall than abrupt, artificially timed waking. This difference likely stems from the body's ability to complete sleep cycles naturally, often bringing consciousness back during or shortly after REM periods when dream recall is optimal. For those specifically interested in remembering dreams, certain supplements have shown promise in research settings. Vitamin B6, for instance, appears to increase dream vividness and recall in some individuals, though the mechanisms remain unclear. Other supplements that affect acetylcholine levels or REM sleep characteristics have also demonstrated effects on dream experiences and recall. The study of dream amnesia bridges neuroscience, psychology, and philosophy. It reminds us that memory is not a perfect recording device, but a constructive process shaped by biology, evolution, and culture. The forgetting of dreams, experiences that can feel profoundly meaningful in the moment, highlights the selective nature of human memory and the gap between experience and recall. Dr. Foster offers this reflection. When we consider dream amnesia, we are really examining the nature of consciousness itself. Dreams show us that we can have rich, emotionally resonant experiences that feel absolutely real in the moment, yet vanish almost completely upon waking. This raises profound questions about how much of our waking experience might similarly be lost, and what the nature of the self really is when so much of our subjective experience leaves no lasting trace. As you wake tomorrow morning, in that liminal space between sleeping and waking, you might catch fragments of the night's dreams before they evaporate. Those fleeting images and emotions represent a glimpse into a different mode of consciousness, one that occupies nearly a third of our lives yet remains largely inaccessible to waking memory. The forgetting of dreams is not simply a quirk of biology but a window into the complex relationship between consciousness, memory, and identity. In the dance between remembering and forgetting, dreams occupy a unique position, experiences that can feel more real than reality while occurring, yet fade more quickly than the most trivial waking moments. This paradox continues to inspire scientific inquiry and philosophical reflection, reminding us that even the most familiar aspects of human experience, sleeping, dreaming, forgetting, contain mysteries at the heart of what it means to be conscious. The scientific study of dream amnesia ultimately teaches us something profound. Consciousness is broader than memory. We are more than what we remember being. Each night, as you drift into sleep, you enter states of experience that your waking self may never access. A testament to the remarkable complexity of the human mind and the many forms of consciousness it generates. And so, as billions of people around the world prepare for sleep tonight, they also prepare for experiences that will likely be lost, dreams that will arise in consciousness only to fade before morning. Yet these evanescent experiences serve crucial functions in emotional processing, memory consolidation, and cognitive integration, whether remembered or not. In the symphony of human consciousness, dreams play their part and then, like notes that have served their purpose in the melody, fade into silence, leaving behind only their subtle influence on the music that follows.